Assalamu alaikum, welcome to my channel. Today our topic is vector addition by rectangular components. Before going further, if you are new on our channel, then please subscribe our channel so that you can get notification of our incoming tutorials. First of all, there is a question that why we use vector addition by rectangular components. There are two methods of adding vectors. The first one is head to tail rule and the second one is vector addition by rectangular components. For adding two vectors, we use head to tail rule, and for adding vectors more than two, we use vector addition by rectangular component method. So let's start. First of all, we will draw a quadrant. We have two vectors, vector A and the other one is vector B. We have a resultant vector which is R, and this R will be equal to sum of A and B. Now we can draw the projection of vector B here. So we will add vector A and B by using head to tail rule. This is vector B, and now we will draw their horizontal and vertical components. So we will draw the projections at their meeting points. So this is the meeting point and we will draw a vertical component, and this is the horizontal component of A and this is vertical component AY. Now we will draw the vertical and horizontal component of vector B. This is vertical component BY and this is horizontal component BX. We will name these meeting point as Q, R or S. Now first of all, we have two vectors A and B and we have the resultant vector R. So R will be equal to A plus B. For the horizontal components on x-axis, Rx will be equal to Ax plus Bx. For vertical components on y-axis, the resultant Ry will be equal to Ay plus By. Now we will represent these vectors in terms of unit vectors. So for x-axis components, we have unit vector I. This is a symbol to represent the unit vector. And for y-axis, the unit vector is J. Now we have two unit vectors. For x-axis, for the components on x-axis, we have I, and for the components on y-axis, we have J. So we will name these equations as 1 and 2. So in terms of unit vectors, Rx I will be equal to Ax. We will place this unit vector here, Axi plus Bxi. Now for resultant of vector on y-axis, Ryj will be equal to Ayj plus Byj. Now we have the resultant of these vectors R. and this will be equal to the r x I plus r y j. Now we will place the values we have named these equations, and now we will put the value of rx and ry in this equation. So equation 5 will become r is equal to ax plus bx into I. Now we will place the values of equation 3 and 4 in equation 5. So r will be equal to a x I plus b x I plus a y j plus b y j. Now we will take common from ax and bx and ay and by. So this equation will become ax plus bx into I plus ay plus by into j. Now we will find the magnitude. So r was equal to r x I plus r y j, and we have the values of rx and ry. So the magnitude of unit vector I or any unit vector is 1. So we will neglect these unit vectors, and we will put the values in the formula to find the magnitude. So to find the magnitude, we have the formula r is equal to rx square plus ry square. Now we will put the values. R is equal to ax plus bx square plus ay plus by whole square. So this was the method to find the magnitude. Now we will find the direction. So this was the method to add the two vectors, and if we have more than two vectors, what we will do for n vector, n number of vector, this equation will become r will be equal to ax plus bx plus cx up to n, and ry will become ay plus by plus cy up to n. So we will place these values. So we will place these values in the above equation. So r magnitude will be equal to the under root ax plus bx plus cx square plus ay plus by plus cy up to n. So this was the by using this method you can find the magnitude of more than 2 number of vectors. So now we will find the direction of vector. Now we will find the direction of resultant vectors. To find the direction of resultant vector, we use the relation tan theta, which is equal to ry over rx. Now we will put the values of ry and rx as the tan theta is equal to the perpendicular over base. So for perpendicular we use y and for horizontal we have x. So for perpendicular resultants, ry is equal to ay plus by plus cy up to n, or ax plus bx plus cx up to n. Now theta will remain as it is and this tan will become tan inverse, and we have the value ay plus by plus cy up to n over ax plus bx plus cx up to n. So this was our tutorial. Thanks for watching. If you are new on our channel, then please subscribe our channel so that you can get notifications of our incoming videos.